ever wondered why some of us get freckles in the sun while others get a deep tan? Or perhaps you've noticed light or dark patches appearing on your skin and wondered what they are. Well, today we're going to unravel the amazing secrets of our skin's pigment and explore the fascinating science that makes every single one of us so unique. All right, so let's start with the most basic question of all. What actually gives our skin its color? It sounds simple, right? But the answer is a wonderfully complex and beautiful cocktail of biology. So think of your skin like an artist's canvas. The final color you see is a blend of 3 different pigments. There's a touch of red, which comes from the hemoglobin in your blood flowing just beneath the surface. There's a bit of yellow, which is from keratin. Yep, the same stuff in carrots. But the absolute main character, the real star of our story today, is the brown pigment called melanin. Now, melanin is made by these special little cells called melanocytes. The best way to think about them is like a dimmer switch for your skin's color. If that switch gets turned down, you get what's called hypopigmentation. That's when you see lighter patches of skin. But if that switch gets turned up, you get hyperpigmentation, which creates darker patches. So today, we're going to look at both ends of this incredible spectrum. First up, let's explore what happens when our skin starts to lose its color. We're stepping into the world of hypopigmentation, where the body's natural palette begins to fade in certain spots. You've probably heard of vitiligo. It's a condition that causes the skin to lose its color in distinct patches. And here's the interesting bit. You aren't born with it. It's something you acquire. But, and this is what's really fascinating, there's a really strong genetic link. For about 1/3 of people with vitiligo, it actually runs in the family. And don't go thinking this is incredibly rare either. It affects about 1% of the entire global population. To put that into perspective, if you were in a packed football stadium, you would be looking at, around 1,000 people in that crowd who might have it. It affects men and women equally and typically shows up when you're between 20 and 30 years old. So what's actually going on here? Why does this happen? Well, scientists have a couple of leading theories. The first one is basically a case of friendly fire. Your body's own immune system gets confused and starts attacking the very cells that produce your skin's pigment. The other idea is that sometimes our nerve endings can release toxic substances that end up damaging those pigment cells nearby. Okay, so what's the outlook for someone with vitiligo? Well, it's a bit of a mixed bag, but honestly, there's a lot of reason to be hopeful. Look at this. A massive 80% of people see some form of recovery. For a full 60%, treatment is really effective. And for another 20%, it can even recover all on its own. Now, for that last 20%, it can be a chronic, lifelong condition, but even then, there are many ways to manage it. Of course, vitiligo isn't the whole story when it comes to losing pigment, not by a long shot. You've got conditions you're born with, like albinism or piebaldism, which causes a white patch of skin and hair right from birth. Then there are a whole host of others that can pop up after something happens, say after eczema, an injury, a burn, or even certain steroid injections. It just goes to show how incredibly sensitive our skin's pigment system really is. All right, so we've talked about losing color. Now let's flip the script and explore the exact opposite, hyperpigmentation. This is what happens when the skin actually gains color, leading to those darker patches. A classic example here is something called melasma. You'll often see it as brown patches on the face. And get this for a statistic, it overwhelmingly affects women. We're talking a ratio of about 15-1, 15 women for every 1 man. And just like vitiligo, it often appears when you're in your 20s and 30s. So what triggers it? Well, it's a whole mix of things, really. Hormonal shifts are a huge factor. Think pregnancy, which is why it's sometimes called the mask of pregnancy, or being on contraceptive pills. But it can also be triggered by stuff you wouldn't even think of, like certain cosmetics, some types of hair removal, or even just friction. And you guessed it, a massive player in all this is sun exposure. So if you get melasma during pregnancy, what happens afterwards? Does it just go away? The honest answer is, it varies. A lot. For about 1/4 of women, it fades away completely. For nearly half, it fades a bit, but not all the way. And for around 30%, it pretty much stays as it is. So yeah, it can definitely be a persistent thing for many people. And again, melasma is only one part of the hyperpigmentation family. You've got your everyday freckles, right? Those little spots that pop up in the summer and fade in the winter. Then there's lentigo, which you could think of as a freckle's bigger, more permanent cousin. You can also get darker patches after an injury or inflammation, and even from some really bizarre combinations like wearing perfume and then going out in the sun. Who knew? Okay, so we've looked at losing color and gaining color. But have you noticed the one common thread, the one factor that keeps popping up again and again in our story? Yep, it's the sun. The sun is an absolutely decisive factor here, and that's what we need to unpack next.
When we say the sun, what we really mean, from a skin perspective, is ultraviolet radiation, or UV light. Now, this light comes in three main types: UVA, UVB, and UVC. The good news is, our atmosphere's brilliant ozone layer blocks pretty much all of the UVC, so we really only need to focus on UVA and UVB.
So what's the difference between them? Okay, here's a simple way to remember it. Think of UVA for aging and UVB for burning. UVA rays are the sneaky ones. They penetrate deeper into the skin and they can even get you through window glass. They're what give you that immediate tan that kind of fades in a few hours. UVB, on the other hand, is the main culprit behind sunburn. It's also what gives you that delayed, longer-lasting tan. Both of them wake up our pigment cells, but they do it in very different ways. Now, of course, not everyone's skin reacts to the sun in the same way. That's where the skin typing system comes in. It classifies skin from type I, which always burns and never tans, all the way down to type V, which is deeply pigmented and rarely burns. The source material for this explainer notes that in Iraq, for example, most people fall into types 3 and 4, skin that tans quite easily. And this is so important because your skin type, your built-in response to the sun, is a huge factor in your susceptibility to all these pigmentary changes. So when you pull it all together, what do we have? Our skin's color is this constant, delicate dance, isn't it? A balance between gaining pigment and losing it. It's a story written by our genetics, our overall health, and, of course, the world around us. And I think this quote just sums it up perfectly. Our skin is not just a protective layer, but a dynamic canvas that tells the story of our genetics, our health, and our environment. It really is, isn't it? Every freckle, every patch, it's just another brushstroke on our own unique personal masterpiece. Which leaves us with one last big question to think about. If our skin's palette is so fluid, so subject to change from our genes, our life, and the sun, what does it really say about our identity? It's a fascinating thing to ponder. Thanks so much for joining me on this journey into the incredible world of skin pigmentation.